This is the Big Idea 3 test, practice test, and the answers for that. I can answer questions about the multiple choice in class. I'm not going to go through each one, but here are my A, B, C, D answers for 1 through 20, the multiple choice. Starting with the free response, we have the zinc and copper. And this is an electrolysis cell. I don't know if you noticed that the cell had an outside power source, so it's running in reverse. So we have zinc plus 2 forming zinc atoms at the cathode, and copper plus 2 forming plus 2, or copper metal at that's the cathode actually, and zinc metal forming, zinc plus 2 forming zinc metal. No, we have copper atoms forming copper plus 2 at the anode. So sorry about that. It's the copper side is the anode, and the zinc side is the cathode. So the zinc side is the cathode because that's where reduction is occurring. So that would be the left side of the diagram. Copper is being oxidized. Normally copper would be reduced at the cathode, but instead in this case the external voltage drives the electrons the opposite way, and copper is being oxidized. I know that because it's losing electrons. The copper ions or copper atoms are losing electrons to become copper ions. As the copper ions form, the copper metal dissolves in the water. So the copper electrode is the one that is losing mass over time. And then the amount of mass of zinc formed is going to be 1.5 amps, 1.5 coulombs per second, times 300 seconds, which is the number of seconds in 5 minutes, times 1 mole of electron per Faraday's constant of coulombs, times 1 mole of zinc over 2 moles of electrons, and 65.38 grams over 1 mole for zinc comes out to 0.15 grams of zinc. Actually, over time, because a copper atom is lost for every zinc atom that deposits, since copper atoms are slightly heavier than zinc atoms, the combined mass of the two electrodes will actually decrease. Will decrease very slowly because we're talking about the difference between 65.4 grams and 63.5 grams per mole. But as copper atoms are lost, dissolving, and zinc atoms deposit, the mass actually changes slightly and goes down a little bit. The particle diagram question involves 10 moles of H2 and 7 moles of O2. In that case, the H2 would be limiting. The reaction is 2H2 plus O2 yields 2H2O. So the 10 moles of H2 are going to form 10 moles of water, but there will be 2 moles of O2 left over. So I tried to draw a picture here with 10 water molecules and 2 oxygen molecules left over. The limiting and excess reactant. Question 3 involved this reaction between HCl and calcium carbonate to make calcium chloride, carbon dioxide, and water. Starting out with the grams of carbon dioxide that you were trying to make, 1.55 grams. 1 mole over 44.03 grams would change grams to moles. And then the carbon dioxide and the calcium carbonate have a 1-to-1 mole ratio. So that is a 0.0352 moles of calcium carbonate. Changing that to grams by multiplying by the molar mass of calcium carbonate, I get 3.52 grams of calcium carbonate. If you had a 10-gram sample, then 3.52 out of 10 would be 35.2% of the sample is calcium carbonate. That means that if the rest of it is silicon dioxide, that 10 minus 3.52 would be 6.48 grams of silicon dioxide. If you change that to moles by dividing by the molar mass, 60.09, you get 0.108 grams of silicon dioxide. Or, I'm sorry, 0.108 moles of silicon dioxide. Mole ratio would be the moles of silicon dioxide over the moles of silicon dioxide plus the moles of calcium carbonate. So the ratio is the moles of silicon dioxide over the moles of silicon dioxide plus the moles of calcium carbonate, which is 0.754. This is the symbol for mole fraction SiO2. Okay, the fourth free response question was the net ionic, complete ionic reactions. So in this case, we have the molecular equation being 2AgNO3 plus Na2SO4 yields Ag2SO4 plus 2NaNO3. Break it down into its ions, 2Ag plus, 2NO3 minus, 2Na plus, SO4 minus 2. Silver sulfate precipitates, so it's written together. 2Na plus and 2NO3 minus, those are our spectator ions, so it's just 2Ag plus SO4 minus 2 yields Ag2SO4. It's a precipitation reaction. Taking liters times molarity for this limiting reactant problem, I find that I have 0.014 moles of silver nitrate times the ratio of 1 over 2 means I'm going to make 0.007 moles of silver sulfate. Using the liters and molarity of the sodium sulfate, I get 0.0135 moles of sodium sulfate. This is a 1-to-1 mole ratio, so that's 0.0135 moles of silver sulfate. So it looks to me like the silver sulfate formed from the silver nitrate is lower, so that means silver nitrate is my limiting reactant. Also, the limiting reactant determines how much silver sulfate actually forms. So 0.00700 moles of silver sulfate form, multiplied by the molar mass, 311.8 grams equal 1 mole of silver sulfate. You get 2.18 grams of silver sulfate. If the actual amount is 2 grams, then 2 over 2.18 times 100 is a 91.7% yield. On number 5, the reaction written should work because silver plus making silver metal is above copper 2 plus making copper metal, so the copper reaction will run in reverse. So yes, it is spontaneous. If you subtract the 2 E naughts, you get 0.46 volts. Zinc plus 2 is above aluminum plus 3, so this one does not work because we want the aluminum plus 3 to run forward and the zinc plus 2 to run in reverse. So that is not the right orientation of those two, so it's not spontaneous, so I do not need to do a voltage. Once again, Fe plus 2 is above Mg plus 2. That's the wrong order, so no, not spontaneous, and no voltage given.